Before the 1960s, cutting down a tree in the Pacific Northwest was a two-man job that took most of a morning. A faller and his partner worked a crosscut saw back and forth through a trunk 4 feet wide, sometimes 5. Douglas fir, old growth, the kind of tree that had been standing since before Columbus. You'd hear the saw working from a quarter-mile away, that rhythmic scrape of steel on wood, and when the tree finally cracked and went down, the ground shook. You could feel it through your boots. That was logging, and for a long time nobody really thought it needed to change. America has been cutting trees since Jamestown, literally since the first English settlers landed in 1607 and needed shelter. Within a generation, the colonies were exporting lumber back to Europe, and the industry never really stopped growing from there. By the early 1830s, Bangor, Maine, was the biggest lumber shipping port anywhere in the world. Over 8 trillion board feet left that port in a 50-year stretch. That number is almost too large to mean anything, but try putting it this way. It was enough wood to build every single house in the continental United States with lumber left over. Then came the Industrial Revolution, the railroads, and suddenly the logging camps pushed deep into places they couldn't have reached before. The Pacific Northwest opened up. Oregon, Washington, Northern California, trees that dwarfed anything on the East Coast, and the men who cut them built a whole culture around doing it by hand or close to it. They had their own language. A faller dropped the tree. A bucker cut it into sections. The whistle punk relayed signals from the work site to the loading area. If you didn't know the vocabulary, you were a danger to yourself and everyone around you. The work was brutal and dangerous in ways that are genuinely hard to overstate. Men died regularly. Crushing injuries, saw accidents, logs rolling on steep hillsides. The pay wasn't great, the camps were rough, and if you got seriously hurt 2 miles from the nearest road in 1930, well, you hoped someone could get to you in time. Still, logging employed hundreds of thousands of Americans throughout the late 19th and early 20th centuries. In some states, it was the economy. The logging camps themselves were their own world. Crews lived in bunkhouses for weeks or months at a stretch, cut off from the nearest town by miles of unmaintained roads or no road at all. The hours were long, up before dawn, into the timber as soon as there was light, working until you couldn't safely see the tree in front of you. The camps were infested with lice more often than not. The food was heavy and repetitive, and there was a particular social code that held everything together. You watched out for the men near you. You didn't take shortcuts that could get someone else killed, and you earned respect by being competent and not complaining about the rest of it. That code was real, and it mattered because in terrain like the Oregon Cascades or the Washington Coast Ranges, one man's carelessness could kill 3 people in under a minute. The logging industry was also male in a way that was essentially total. Women weren't in those camps in any working capacity, children were kept far away, and the whole enterprise had a kind of relentless physical masculinity built into it. There's a mythology around the American lumberjack, Paul Bunyan and all of that, and it wasn't entirely invented. Men in those camps were genuinely tough in ways that came from doing physically demanding and dangerous work every single day. The mythology just left out the part where so many of them came home injured or didn't come home at all. Then World War II happened. The war changed everything about American industry, and logging wasn't spared. Lumber demand went through the roof. The army needed wood for everything: barracks, crates, docks, bridges. A propaganda poster from that era put it plainly. Lumber production is falling behind our war needs. To save American soldiers' lives, we must provide the lumber our armed forces need now. The workforce was already stretched thin because so many men had shipped out, and the industry desperately needed a way to cut more wood with fewer people. That pressure accelerated the adoption of the gasoline-powered chainsaw. Andreas Steele had actually invented the first gas-powered model back in 1929, but it took the war's urgency to really push chainsaws into widespread use across the Pacific Northwest. A 2-man crosscut saw crew suddenly became a 1-man chainsaw crew. That was genuinely significant. Faster cuts, fewer people needed per tree. But the chainsaw, as game-changing as it was, still required a human being to stand next to the tree, operate the saw, control the fall. You could speed up the cut, but you couldn't remove the man from the danger zone. The other thing the chainsaw didn't fix was the filing. Old-timers who worked with the early models spent nearly as much time maintaining the chain as they did cutting. Joseph Cox, an Oregon lumberjack, figured out a better tooth design in 1947 after watching a timber beetle larva chew through solid wood in a tree stump. He spent months studying how the insect's curved mandibles worked before translating that geometry into a cutting chain that stayed sharp longer and required less maintenance. Cox's design eventually became the standard. It's still the basis of most chainsaw cutting chains sold today, decades later. One person watching a bug eat through a stump, and it changed something. Those kinds of fixes helped, but the chainsaw was still fundamentally a handheld tool. A man still had to stand within arm's reach of a falling tree, weighing tens of thousands of pounds. After the war, as the logging industry expanded again to feed the post-war construction boom, the accident numbers were grim. Chainsaw injuries, trees falling the wrong direction, log decks rolling loose on landing areas. The industry kept hiring and the timber kept moving, but the human cost was consistently high. That gap between what a chainsaw could do and what the industry actually needed is where the next chapter of this story begins. Robert Probst grew up in Colorado in the 1920s, the son of a family that wasn't wealthy but valued education and making things. He was restless in the way that some people just are, the kind of person who can't look at a system without immediately cataloging everything wrong with it. He studied at the University of Denver, worked as a graphic artist and sculptor for a while, and in 1953 started his own company in Denver, focused on what he called speculative product development, meaning he would look at industries that had problems nobody was seriously trying to solve, and he'd invent solutions whether anyone asked him to or not. The way Probst worked was unusual enough that it's worth describing. He didn't start with an idea for a machine and then go looking for a problem it could solve. He worked the other direction, spending time in actual workplaces, actual forests, actual hospitals, watching what people did with their bodies and their time, and asking where the friction was. Where did workers have to do something repeatedly that made no physical sense? Where was the danger coming from, and why hadn't anyone designed around it? His approach to the logging industry came from the same place his approach to office furniture came from. Spending time with the people actually doing the job and taking seriously what they said was hard about it. People in industries tend to normalize their own discomforts over time. You get used to the filing, you get used to the dangerous angles, you stop noticing the things that are quietly making the work worse than it needs to be. An outsider watching with fresh eyes sometimes catches things that insiders have long since stopped seeing. That was Probst's real skill. He hadn't spent 20 years in the timber industry, so nothing about it seemed inevitable to him. Every dangerous or inefficient step was just a problem that hadn't been solved yet. One of those industries was logging. By the early 1960s, Probst had landed at Herman Miller, the Michigan furniture company, where he was given an almost absurdly open mandate: find problems outside the furniture industry and figure out ways to fix them. His formal title was president of the Herman Miller Research Corporation. In practice, it meant he spent his days roaming across sectors of the American economy, watching how people worked, noting what made no sense, and building things. He would eventually hold over 120 patents across fields that had almost no relationship to each other. A livestock tagging system, a mobile office for people with quadriplegia, a workflow system for hospitals, and something called a vertical timber harvester. The timber harvester he was developing in the early 1970s addressed a problem that the chainsaw hadn't touched. The physical act of felling, gathering, and moving trees was still almost entirely dependent on men working on the ground, in the fall path of enormous logs, in terrain that ranged from mildly difficult to genuinely treacherous. The Pacific Northwest in particular, steep hillsides, wet ground, enormous old-growth timber, was a place where a logging crew could do everything right and still lose a man on a bad day. Probst wasn't the only one thinking about this. Out in the Midwest and across the logging regions of the country, other inventors and fabricators were working on similar problems from different angles. Irv Drott, a heavy equipment manufacturer, had built an early track-type feller buncher in the late 1960s. The concept was straightforward enough. Mount a cutting head on a machine, use it to fell the tree, and use the same machine to gather and stack several trees at once before the operator ever had to move. You could take a man out of the most dangerous part of the job, standing on the ground next to a falling tree, and put him in a cab. The early machines were enormous and ungainly. They worked mostly, but they were slow to maneuver and struggled on anything but relatively flat ground. And the logging industry, especially in the South and the Pacific Northwest, was not known for flat ground. The refinement came in stages. Carroll Nelson and Len Vicina developed the Hydroax in the 1970s, a hydrostatic wheel-type feller buncher that was far more maneuverable than the track-based machines. Hydraulic systems allowed for better control, more precise cutting, and the ability to hold multiple stems at once while the operator positioned the machine for the next tree. By the early 1980s, John Kurelek at Kuring Waterous introduced disc saw heads, circular saw blades that could cut through a trunk continuously without stopping, which dramatically reduced the time per tree and produced a cleaner cut that made the lumber more valuable. Each of these improvements built on the one before it, and what they were collectively building toward was something the industry had never really had. A machine that could do in minutes what used to take a crew of men most of a day. To understand just how big a deal that was, you have to understand what logging looked like on the ground before mechanization. A typical crew in the 1950s or early 1960s consisted of a faller and his partner working the chainsaw, a bucker cutting the felled trees into log lengths, a skidder crew using cables or tractors to drag logs to a landing area, and then a loading crew to get everything onto trucks. That's a lot of people doing sequential tasks, and each handoff was a place where things could slow down, go wrong, or cost somebody their safety. A feller buncher didn't just replace one worker. It compressed several steps of that process into a single machine with a single operator. The machine drives up to a tree. The cutting head grabs the trunk. The saw cuts through the base in a matter of seconds, and the machine holds the tree as it falls, controlling where it lands, preventing it from smashing into other trees or rolling down a hillside. Then the machine repositions, grabs another tree, and stacks them together into a bunch that a skidder can collect. What used to be a morning's work for several men could now be done in under an hour. That kind of productivity shift does complicated things to an industry. On one hand, it made logging dramatically safer. The number of fatalities in the American logging industry declined significantly as mechanization took hold through the 1970s and 1980s, which is an unambiguous good. Men who would have died doing dangerous jobs close to falling timber were now operating machines from enclosed cabs. The machines could work in conditions, steep slopes, wet weather, poor visibility, that would have slowed or stopped a hand crew. On the other hand, fewer machines meant fewer workers. A job that once supported a crew of 8 or 10 could now be done by 2 or 3 people with the right equipment. Logging towns across the Pacific Northwest and the South felt that contraction. Mills started automating too, and the combination hit some communities very hard. The argument about mechanization in the logging industry was the same argument that plays out whenever a new technology reshapes manual labor. The work gets safer and more efficient, And the workers who remain are better off in a lot of ways, but there are simply fewer of them. The men who lost work to these machines were not abstractions. They were people who'd built their lives around a particular set of skills, knowing how to read a tree, knowing how to work a saw in difficult terrain, knowing the particular physical language of a logging crew. Those skills didn't transfer cleanly to operating heavy equipment. Some older fallers adapted, a lot didn't or couldn't, and the towns built around seasonal logging employment. Small places in rural Oregon or Mississippi or Georgia that didn't have much of an economic base outside the timber industry absorbed those losses in ways that are still visible today. It's also worth noting that the transition wasn't sudden. Mechanization moved through the industry gradually over roughly 2 decades, faster in some regions than others. The South mechanized earlier and more thoroughly than the Pacific Northwest, partly because the terrain was easier. Flatter ground meant the first-generation machines worked better. In steep country, hand crews and chainsaws remained competitive longer because early feller bunchers genuinely couldn't operate safely on the grades that characterized a lot of Pacific Northwest timber country. The more capable machines took time to develop, so the displacement happened over long enough a period that it looked less like a single shock and more like a slow erosion. That doesn't mean it hurt less for the people it affected. It just means it happened without much public attention, in the kind of places that rarely get public attention. It's a real tension, and it's worth sitting with rather than resolving too quickly. Back to Probst for a moment, because his story has an interesting wrinkle. The vertical timber harvester he was developing in the 1970s was just one of the things he was working on, and frankly, not the thing he's most remembered for. That would be the Action Office, a modular workplace furniture system he designed for Herman Miller that introduced the concept of reconfigurable partitions. The thing that eventually became, in forms he never intended and actively despised, the office cubicle. When companies took his open adaptable workspace design and crammed people into tiny partitioned boxes, Probst was furious. He called those environments hellholes and rat-hole places, and spent his later years distancing himself from what had been done to his idea. The timber harvester got less press, but it was part of the same underlying project. Probst looking at how human beings actually did physical work, finding the places where the system made no sense or created unnecessary danger, and building something better. Whether that was an office furniture system or a machine for cutting down trees in a Pacific Northwest forest, the impulse was the same. By the late 1980s and into the 1990s, the feller buncher had become a standard piece of equipment across logging operations in the United States. Tiger Cat Industries, a company formed in 1992, partly because loggers in the American South wanted a high-quality drive-to-tree buncher that existing machines weren't delivering, became one of the dominant manufacturers. Their machines, and machines from John Deere, Caterpillar, and a handful of specialized forestry equipment companies, kept getting more capable. Self-leveling cabs for steep terrain. Disc saws capable of cutting through timber several feet in diameter. Electronic controls that gave operators precision that the earlier hydraulic systems couldn't match. Today's feller bunchers are extraordinary machines by any standard. A modern Tiger Cat or John Deere feller buncher can process several hundred trees in a single shift. The operator sits in an air-conditioned, sound-insulated cab with glass all around, controlling movements through joysticks with the kind of precision that would have seemed like science fiction to a logger working a crosscut saw in 1930. The machines run on diesel, they're heavy, the bigger ones top 30,000 pounds, and they cost hundreds of thousands of dollars. But measured against the cost of employing a full manual crew or against the cost of worker injuries, they pay for themselves. The environmental dimension of all this is complicated and worth at least a moment. Mechanization didn't create clear cutting. The Practice of stripping entire hillsides of timber goes back much further than the feller buncher, but faster, more powerful machines did make it easier to harvest timber at a larger scale and faster pace. The environmental conflicts that erupted in the Pacific Northwest in the late 1980s and early 1990s, what got called the Timber Wars, were partly a response to just how efficient modern logging had become. Protesters who chained themselves to old-growth trees in Oregon were responding to the fact that a few machines and a small crew could remove a 100-acre stand of timber in a week. That wasn't possible in 1940. The logging industry today operates under far more regulatory constraint than it did in the mid-20th century. Environmental review processes, old-growth protections, habitat preservation requirements. The machines are still there and still productive, but the context in which they work has changed substantially. Modern sustainable forestry at its best uses those machines to manage forests deliberately. Thinning overcrowded stands, removing diseased timber, harvesting planted tree farms in rotational cycles designed to keep the land producing indefinitely. That's the version of the story that the industry prefers to tell about itself, and in fairness, it's largely accurate for the companies doing it right. The version Probst would probably recognize: a person looking at a system, finding where it creates unnecessary cost and danger, and building something that works better, is what drove every step of this machine's development. From Irv Drought's first ungainly track-type prototype in the late 1960s to Carroll Nelson's more maneuverable hydro axe to the precision hydraulic machines of today, the feller buncher is a direct line from one person asking a simple question: why are we still doing this the hard way? Robert Probst died in the year 2000, a few months before his 79th birthday, in Ann Arbor, Michigan. He held 120 patents. Most obituaries focused on the cubicle, the thing he built that was turned into the thing he hated. The vertical timber harvester got a line or two if it got mentioned at all. That's often how it goes with people who invent things that work as intended. The machines get used, the industry changes, and eventually nobody thinks much about who started asking the question. The old crosscut saws ended up in museums or hanging on walls in Pacific Northwest bars as decorations, which is exactly the kind of fate a tool earns when a better one comes along.